Welcome to True Projects. In this video, we are going to explain about the project, which is an integrated two-layered voting TLV framework for coronary artery disease prediction using machine learning classifiers. So, before getting into the execution, first let's understand what is the project about. These days, technology is such a big part of our lives that isn't changing how we live for better or worse. So, with so many people nowadays, they are spending long hours on the screens, that is, the systems, and staying inactive. Habits like poor diets, smoking, and lack of exercise are being mostly common in all the people. But all these lifestyle choices they contribute to the growing problem called cardiovascular diseases. And one such problem is coronary artery disease. So this occurs when the arteries supplying to the blood to the heart get narrowed or they will be blocked due to the plaque buildup. This can lead to the chest pain or worse, and also it will lead to heart attack. But this coronary artery disease doesn't develop overnight. There are some risk factors. So those risk factors are high blood pressure, that is nothing but the hypertension, obesity, diabetes, and stress buildup over time, making these things worse. For instance, if someone has hypertension and diabetes, the risk multiplies, like how neglecting small issues in the car leads to the breakdown. That's why early detection is very important. Identifying high blood pressure or abnormal blood sugar levels can prevent serious complications. But there is a tricky part: these risk factors don't act alone, they interact in complicated ways, making it harder to predict outcomes. For example, someone with stress might also have poor sleep, leading to weight gain and also the heart issues. So, this is where machine learning steps in. So, this is where machine learning comes into the picture. This will help make sense of these complex interactions by analyzing large health data sets. With this, doctors can spot patterns earlier, giving people a better chance to stay ahead of heart disease. And some existing machine learning models. So these machine learning models, they have some limitations. That means they face some challenges. With the limited data sets, they face the issues with the irrelevant features and also the suboptimal performance. Many studies they rely on popular data sets like UCI. But there is still gap in finding effective methods to handle this growing data and extract meaningful patterns. And here with the problem called limited data set is the data set will be so limited, and with that dealing predicting heart disease is hard. And coming to the irrelevant features, we must pick up the most important data points to improve the model accuracy, as the old machine learning models they were unable to do. And also, fine tuning the models is also important for accurate prediction. Moving on to address all these challenges, in this project, we are introducing machine learning based models with focusing on improving accuracy and handling large data sets. So, here we are using two main data sets. One is Kaggle heart disease data set containing 70,000 records in it, and UCI data set. And in this project, we are incorporating two-layered approach, which is an ensemble approach. So here we will be implementing an ensemble approach in which individual machine learning classifiers will be incorporated. That is, we will be building multi-layer perceptron decision tree, support vector classifier, and random forest. So these models, they will be individually built. After building them individually, we will be combining them in the voting classifier, that is called two-layered approach. And here voting classifier will be built two times, one with the voting mechanism, that is soft voting mechanism, and one with the hard voting mechanism. So these two are the prediction mechanisms in the ensemble models. Moving on, we will be fine tuning them using the grid search CV model. So this is about the proposed system. And coming to the extension, to improve the performance, further we have implemented stacking classifier, which also combines multiple individual models. So here we have incorporated stacking classifier to further improve the performance. And also, as a front end, we have view a Flash framework to build the front end. So this framework, this approach, it will facilitate user testing and offers a smooth interface for the users. So we have included user authentication to ensure secure access to the system. Moving on, we have used these algorithms in the project. So we have used decision tree, support vector machine, random forest, multi-layer perceptron. And this is the proposed system where we have implemented two layers. So in the first layer, we have implemented the voting classifier in which we have combined all the four support vector machine decision tree random forest MLP algorithm. So we will be combining all these models in the voting classifier. And here we will be using soft voting mechanism to predict the heart disease. And coming to the second voting classifier, here we will be combining all the four models, but we will be using the hard voting mechanism to predict the heart disease. And as the extension, we have incorporated stacking classifier. So this model has performed well among all the models built. So we will be deploying it in the front end to detect the heart disease. Moving on, these are the steps followed to implement the project. Let's understand each of the steps. So first, we import the required packages to implement the project, and then we explore the dataset. So here we explore the Kaggle dataset as well as the UCI dataset. And then we process the dataset, we clean the data, and we drop the unwanted columns. Then we visualize the data using sample outcome, which shows the distribution of the classes, and then we convert categorical data to numerical using label encoding technique. Then we append all the features to X variable and target to Y variable. Then we select features using chi-square, mutual info, and ANOVA feature selection techniques. So we will be using all those three feature selection techniques and we will be building the models. And then we split the data into train and test. Train set will be used for training the models and test set will be used for evaluating the models. So coming to building the model, here we will be building the model and that too, it will be trained on all the features extracted from all the three different feature selection techniques. That means, so these, all the models, 7 models will be implemented on features extracted using all these feature selection techniques. Moving on, then we will be comparing all the algorithms using accuracy, precision, recall, and FN score. So we have used these metrics to evaluate all the models which are built in the project. Then we compare all those using graphs, and we have developed front end using Flask framework, which is integrated with the SQLite3 database. And in the front end, users they will be able to give the feature values. That feature values will be pre-processed at the back end, and it will be fit with the train model that will be giving the prediction in the front end. So to implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. So coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. This is all about the theoretical part of the project. Let's execute. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let's understand them first. What are they? So here the first two folders we have is dataset folders. So in the first heart disease folder, this is the UCI's heart disease dataset, and the Kaggle is the Kaggle's heart disease dataset, which is in the Kaggle folder. So we will be using both of the datasets to train the models to detect the heart disease. And here in the models folder, we have the algorithm information that will be loaded into the project code during runtime. Coming to static folder, inside this folder, there are files related to CSS, JavaScript, and Bootstrap files. They are important for the visual appeal of the project. Coming to the templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here in this app.py file, this .py file contains the information related to the front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have two Jupyter Notebook files. So these files contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And here in this first Kaggle Jupyter Notebook file, we will be having code related to Kaggle data. So first we'll be loading the Kaggle data set, and on that data set we will be training the models. So coming to this UCI Jupyter Notebook file, here we will be having code related to the UCI data set. So here we will be training all the models on the UCI data set. And this is the signup.db file. This file is a database file which is used to store the user information. And here we have the test cases files. So in this, both the files, we have the test cases that we will be using in the front end to detect the heart disease. In the sample Kaggle file, we will be doing prediction for the Kaggle dataset. So we will have test cases in the sample Kaggle file. Similarly, in UCI sample file also. Let's execute. To execute, we need to copy the path of the code folder from the address bar of the file explorer. So copy the path. Now open the Anaconda prompt. So now we have to give the command cd following by the space, copy the paste the copied path. Now click on enter. Here if you observe, current directory is changed to the code folders path. Now we have to compile app.py file. So give the command python space app.py and click on enter. So this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I prefer Google Chrome, so I will paste it in that. Paste the link here. We have copied the path. I mean, link has not been properly copied. So let's copy it, get back to the code, get back to the browser, paste it here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So first we have to register, click on register and enter all the sign up details if you are registering newly. I have already registered, so I'll directly sign in. So click on sign in and give your username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So we will be doing prediction for both the data sets. So first let's do for the Kaggle data set. So click on Kaggle. So here we have parameters related to Kaggle dataset. So we need to give inputs to these parameters. Based on the given inputs, we will be getting the prediction. So first let's understand what are these. So the first one is the age of the person. This is the age of an individual, which is significant risk factor for heart disease as likelihood increases with the age. Coming to gender, this indicates whether the individual is male or female as heart disease risk varies with the gender. Coming to weight, this is the individual's body weight, which can impact the cardiovascular health and overall risk factors for the heart disease. Coming to APHI, it is the high blood pressure. This refers to the systolic blood pressure reading, which indicates the pressure in the arteries when the heart beats and it can affect the heart disease risk. Coming to APLO, it is the low blood pressure. This denotes the diastolic blood pressure reading, reflecting the pressure in the arteries when the heart rests between beats, and it is also important for the health. So, coming to cholesterol, it measures the total cholesterol level in the blood, as high cholesterol can lead to plaque buildup in the arteries, increasing heart disease risk. Coming to gluc, that is GLUC, this refers to the blood glucose level, which can indicate diabetes or insulin resistance, both of which are significant risk factors for heart disease. Coming to smoke, this indicates whether individual is a smoker, as smoking is major risk factor that can damage blood vessels and contribute to the heart disease. Coming to alcohol, this specifies the individual's alcohol consumption habits, as excessive alcohol can intake can affect the heart health and also increase the risk of heart disease. Coming to active, this denotes the individual's level of physical activity, as regular exercise can help lower the risk of developing heart disease. So this is about the parameters of Kaggle dataset. Let's give inputs to these parameters. For that, we have to open the sample file. So get back to the code folder. So this is the file that we will be opening, in which we have the test cases. So open it. Let's give the input feature. So let's try with the second test case. So here we need to give the date of birth of the person. Let's enter it. Next, the gender. So the gender is 0, which means the person is male. And then weight of the person is 60. ABHI is 120, that is systolic blood pressure. And diastolic is 120. Sorry, it is 80. And the cholesterol level is 0. Glucose value is also 0. Smoke is also 0. And alcohol value is 0. Active value is 1. Still we need to enter. We have entered all the parameters. Now click on predict. The given input, it will be pre-processed at the backend, and then the trained model will be fit to this, and we will be getting the prediction. So here we got the prediction that predicted as the patient with no heart disease. So the application is predicting that patient has no heart disease. Let's try with the other set of inputs. So click on prediction, click on Kaggle. Let's try with this test case. So here the age is 118117, and give the gender, give the weight of the patient, give the APHI, that is 120, APLO is 80, cholesterol value is 0, glucose is 0, smoke is also 0, alcohol is 0, active value is 1. Now click on predict. So based on the given information, here we got the prediction that patient has no heart disease. So the application is predicting the patient has no heart disease. Let's try with the this test case for the same data set. So give the date of birth of the person. By that, it will calculate the age. Gender is 0. Weight is 77. APHI value is 140. APLO is 90. Cholesterol value is 1. Glucose value is 1. Smoke is 1. Alcohol is 0. And active is also 0. Now click on predict. So based on the given information, here it has predicted as patient with the heart disease. So it is predicting the patient is suffering with the heart disease. Now let's do prediction using the other data set. So click on UCI. So here also we have some parameters that are need to be given. Let's understand them first. So as we know, it is the age of the person. The next one is sex, which is gender of the person. Next we have is CP, which is chest pain type. This refers to the type of chest pain experienced, and it is characterized into different types: typical angina, atypical angina, non-anginal pain, that indicate variety levels of heart disease risk. The next one we have is REST ECG. It is resting electrocardiographic results. This measures the heart's electrical activity while at rest, helping to identify abnormalities that may signal heart disease. Coming to Talaj, it is the maximum heart rate achieved. This indicates the highest heart rate reached during exercise or stress testing, as a lower maximum heart rate can be associated with the heart higher heart disease risk. Coming to exang is the exercise-induced angina. This specifies whether the individual experiences chest pain during physical exertion, which can be a sign of underlying heart issues. Coming to old peak, it is a depression induced by exercise. This measures the STs, depression induced by exercise related to test. This can indicate heart disease. Coming to slope, this describes the slope of the peak exercise ST segment, which can help assess the likelihood of the heart disease based on the heart's response to exercise. So coming to CA, it is the number of major vessels colored by fluoroscopy. This counts the number of major coronary vessels with significant narrowing, with more affected vessels indicating a higher risk of heart disease. Next one is TAL, that is thalassemia. This refers to the thalassemia status, that is normal fixed defect or reversible defect, which can provide insights into the heart's health and risk associated with the blood conditions. Now let's give inputs to all these parameters. So we have to open the sample file. Let's open the sample UCI. So here, let's try with the first test case where age of the person is 45, gender is 0, which means the person is male, CP value is 2, rest ECG is also 2. The large value is 138. The next one we have is exang, which is 0. Old peak is 0. Slope is 2. CA is 0. Tal value is 3. Click on predict. So here we got the prediction that patient has no heart disease. Let's try with the other test case for the same UCI data set. Click on UCI. Let's try with this test case where age of the person is 50, gender is 0, CP is 3, STCG is 0, Talach value would be 158, exang value is 0, old peak is 1.6, slope value is 2, CA value is 0, Thal value is 3. Click on predict. So based on the provided input here, we got the prediction that patient has no heart disease. So let's try with the other test case. So let's try with this sixth test case. So the age of the person is 53, gender is 1, CP is 4, SCCG is 2, Talach value would be 155, exang is 1, old peak is 3.1, slope is 3.1, sorry, slope would be 3, and CA is 0, Thal is 7. Click on predict. So here we got the prediction that patient has the heart disease. In this way, just by giving inputs to the parameters based on the data set, then we will be getting the prediction whether the person will have heart disease or not. Let's check with the graphs for the Kaggle data set. So click on that. So here we have the graphs. So this is a sample outcome graph where on x-axis we have the class and on y-axis we have the count of each class. If you observe, both the classes are almost equal. And here we have the accuracy graph where on x-axis we have accuracy score and on y-axis we have the algorithm names. So here if you observe, extension is having the highest accuracy than any other model. And this is the accuracy graph after tuning all the models with the hyperparameters. And this is the precision score comparison graph. This is recall score comparison graph. And this is FN score. And here we have accuracy comparison graph for the chi-square feature selection, which means that from the Kaggle dataset, we have selected important features using chi-square technique, and then we have built all those models on that feature selected dataset, that is chi-squared feature selected dataset. So if you observe, extension is having the highest accuracy. And here we have precision, recall, FN scores. And here we have for the mutual info feature selection technique. All these are the graphs. And here we have the ANOVA feature selection technique. So if you observe here also extension is having the highest accuracy. So this is for the Kaggle datasets. Now let's try with the UCI dataset. So click on UCI. So this is the sample outcome graph where on x-axis we have the target class, classes in the project, and on y-axis we have the outcome. If you observe, one class is less than the zeros class. And here is the accuracy graph, accuracy comparison graph after tuning all the models with the hyperparameters. So if you observe, extension is having the highest accuracy. And here we have precision score comparison graph, recall score, F1 score, and here we have the chi-square feature selection technique. Here we have selected features from the UCI dataset, and all these models are built on that feature selection technique, all the features which are selected from the chi-square feature selection technique. And here this is the precision, recall, FN score, and here we have for mutual info feature selection technique. So now click on log out. In this way, by using feature selection techniques and machine learning models, that is the two-stage ensemble model and the extension model stacking classifier, we were able to build accurately the disease, that is the heart disease. So this will help the doctors and also the patients who have this disease. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.